All right. So hopefully you guys enjoyed the breakout sessions and getting to know each other a little bit and introduced yourselves to each other. We've gotten a couple questions, and more are going to be coming in. I'm asking Eva, Frederick, and Roberto to kind of feed them to me, and we'll see which ones are most common, and we'll start answering those. One that came up in the breakout session that Frederick told me about is people had a question about reality. And so what do you do in practice when you've got thousands or hundreds of thousands, tens of thousands of SKUs? What do you do with this? Do you do it in Excel? And of course you don't. The only reason we use Excel is because it makes you learn the fundamental concepts. I don't know anyone who's done a network design in Excel in real practice, but every package that's out there, whether it's Supply Chain Designer, LlamaSoft, all the different ones out there, they use a mixed integer linear program at the heart of it, every single one of them. So you learned the basics that are at the core. Everything else that's out there in practice, usually the focus is on the user interface, so it makes it easier for you to enter in the data, manipulate things. That's where the real value comes in. But at the heart of it, the mixed integer linear program, constrained optimization, is the way they all solve it. They are all optimization-based problems. But what do you do when you have tens of thousands of SKUs? So what people do is you aggregate them by families. And so you look at what is common. So you look at the families of products that have the common characteristics. Either they look the same, they have the same physical characteristics, you can treat them that way, or they have the same demand characteristics. And I think I talk about in week 3 about the flow unit. So you think about what the common flow unit is, and you kind of aggregate things into those categories. That's usually one of the hardest parts of a supply chain design project, is coming up with the data. Running the optimization typically is the easiest part. The hardest part is figuring out, okay, what are we going to include? What is in scope? What is out of scope? Because as I talked about a little bit in week 3, the more you get people involved, they want to add more and more complexity in. And there will always be someone who says, we want to model every SKU to every location, and that's just insane, right? You always want to simplify it. As I said in some of the lectures, these models are caricatures. They're not portraits. They're caricatures of the network. And so they give you insights to make decisions. The model isn't going to tell you what to do exactly. So there's a bunch of different package software that's out there. I can send a link out. I'll do something on the discussion forum. There's some I can name off the top of my list, but that's not fair to some of the other ones. So I'll send out a list of some of those that are there. And if you contact them, they'll be glad to tell you everything about their models, their software, because they're selling them. But the idea of going from many to few, that's a challenge. And the best advice I can give you is to meet with people and figure out what is the most important thing you're trying to get out of it, and have as few SKU families as possible. Someone else asked about textbooks, and so I recommended a number of them in the key concept doc, right? And so the 2 that I would recommend for these practical questions, Watson's Lewis Cacioppi and J.R. Raman's Supply Chain Network Design is the best, because it's really practical. These are the guys who were part of the project team, one of the most widely used systems that are out there. So I would highly recommend that for very practical things. Jeremy Shapiro's book, Modeling Supply Chain, is also very good. It's harder to find. He passed away about 8 years ago, and the last edition obviously came out about 8 years ago. So it's getting harder to find now. All right, so some other questions that came in. How do you handle stochastic demand in network design problems? Typically, you don't. You ignore it, right? And so what you try to do is find out what the steady state is, and you can add capacity to that. So we talked a little bit about this in week 3, because what you really want to do is say, okay, what happens if I have this seasonality, big changes in demand? Because remember, you're setting your safety stock to handle some of that minor variability, right? So my safety stock will handle my daily variability. If you're going to have big swings going through, then you can plan for those as separate seasons. But remember, when you do network design, it ignores inventory until you, remember we did that approximation for the curve where you're looking at the pooling effect. You can add that in, and I don't go too far into that. Go to Jeremy Shapiro's book. That's the only textbook I've seen that really goes into more detail for it. But we go in about as much detail in the lectures as he does in the book. So you can add the additional inventory into it. The other thing you can do is what we did in week 3 is if you have, you can run this in multiple times. you can almost run a simulation of the demand and optimize it each time, and you can see which of the different facilities, for example, are most commonly opened. That's a common kind of poor man simulation that works fairly well. There are some, if you want to get into research areas, stochastic network design is a hot area. People have a bunch of different techniques for it. Bert Stemus has come up with robust network design, where you have like a robust budget. We've done some work here with Dr. Francisco Geoffrey that has looked at using a loss function. You do a linear approximation of the nonlinear loss function and include that in the optimization. In a project that he did with myself for Walmart a couple years ago, we did that to help them design their flow of dedicated fleet over stochastic network demand. So there's some techniques there. There's some research-oriented ones, and on the practical side, I would recommend doing a simulation. All right, so another question, what mathematical skills do you need to model these kind of problems? You need mad mathematical skills, right? You need everything that we do. Honestly, so the way I think about this is we are teaching you how to drive a car. When you learn to drive a car, you don't go and learn how to drive on a Honda, and then a Toyota, and then a Ford, and then a Chevrolet. They're all a little bit different, but basically there's a way to drive a car. So we teach you those fundamental things. Every car will be a little different, but we're not going to train you on the individual ones. We're going to teach you and educate you on the fundamental way to drive, to design a supply chain. Now the question is, how deep do you want to go? Do we want to get down to, using the car analogy, do I want to understand how to build a combustible engine? Do I want to get to that level? And in this course, we are not going to that level. We're not doing proofs of the mathematical theory, but we're going a little higher than that. You need to know, you don't need to know how the engine works specifically, but you need to know what the inputs are. You need to make sure you know whether to put diesel in or gasoline or plug it in for electrical. So you need to know the inputs. So you need to know enough to make sure you can really drive the car properly. And so that's why we make sure you understand the fundamental models, but really you're only learning them enough to be able to apply them. So you know what it can and can't do. There are other courses, and I can recommend some, where you go much deeper into the math, and you can go a lot deeper and understand the theory and some of the cutting edge kind of things. But the math that we've done in this course for the first 3 weeks, that's more than sufficient to be part of a network design team. All right, so how do I convert to a nonlinear problem in a linear problem? There's a couple ways you can do that. You can do an approximation. So if I have a linear function, or nonlinear function, and we do this a little bit when we talk about inventory. So let's say I have a concave nonlinear function for inventory. What I can do is say, okay, over a certain period, I'm going to do a linear approximation of it. In fact, can I do that on the board? Can you guys see this? Yeah. All right. This is fun. So, is that in the board?
Yeah. Yeah.
It's kind of there. So let's say I've got something like this. So what I would do is a linear approximations like this. And so for each zone, essentially you're giving it a linear cost. And so all you do is, it's just called linear approximation. So you create 3 zones and you give each one a separate slope. And so that's something that is widely done. Now, if you use a packaged software, you will never get to this. They don't care. But you could probably enter in zones where a certain variable cost. So what you're doing is putting a variable cost in a linear function that captures that nonlinear function. All right, so I talked about software. So let me see what other questions we have. So how do I include a model with a fixed cost for a manufacturing plant? I think I covered that. Didn't I cover that, Frederick? The fixed cost in there? And so essentially you can put that in the objective function. So the cool thing is you saw how you can build the objective function, right? And the constraints. You have so much flexibility. But typically you've got a fixed cost if something comes in or not. And if you have something come in with a certain, if it's a continuous variable, you can add a variable cost to it. So it'd just be, you'd have to do 2 things. You'd have to have a binary variable, right? That triggers if anything, let's say it's a plant, so anything coming out of it. So if anything comes out of it, then it gets turned on, right? So call that Y sub I. So when Y sub I gets turned on, then all I have to do is a fixed cost to it. If I have a variable cost for every output, then I simply have whatever that variable X sub I of the amount of product coming out, I can put that in the objective function and charge that as well. So there's really 2 ways you can do that. And the cool thing that I hope you realize from network optimization, you can have hard constraints and soft constraints. And if you took SC2x, you saw the same thing. No, actually, they haven't seen that yet. They'll see that when Yossi talks about it. Was that in 3 weeks? Yeah. So you'll see this again when we do procurement, where you can enforce things hard or soft. By hard, I can put a restriction in. And we did this for network design, saying no more than 3 plants, the 4 DCs. I can do the same thing when I use this for procurement as well. You can also do a soft constraint, say each one that comes in, I'm going to charge $1,000, $10,000, $1 million. And they each have the same effect. As I ratchet up that cost, it's going to make it, it'll recommend fewer and fewer facilities versus a hard constraint. And so there's benefits doing them one way or the other, and we'll talk more about that because you'll see more of these optimization models in weeks 7, 8, 9, and 10. So you're not getting rid of them yet. All right. So what other questions do we have? Okay. Clustering. Yeah, so this is great comment. I don't know who sent this in, but another way to figure, when we're talking about SKUs, I've got 10,000 SKUs. How do I figure out which ones to put together? There's a technique called clustering, and there's a bunch of variants to it. K-clustering is one. There's a bunch of different ones. And what clustering analysis does, it says, I've got all these little objects or items. They can be locations, they can be SKUs, they can be anything. And so you have these, and they each have characteristics. So I've done clustering a lot in locations, and this might be one way to get regions together. So every location has a latitude, a longitude, and some other characteristics. Let's say it's a certain demand characteristic, a certain demographic, number of women, income level, whatever. And then what this clustering techniques, whether it's k-means or other methods, they try to put these together in groups such that the variability within the group is less than that between the groups, right? And so it's a way of breaking things down. So if you're interested in that, look up k-means clustering or just clustering algorithms. There's a lot out there, and it's a really popular technique. All right. Many supply chain jobs ask for you to have Excel skills. Are they out of sync? No, no, no. So Excel, I make fun of it, but it's better than LibreOffice anyway, right? And we only use LibreOffice because we have to provide something free. That's the only reason we do it. I wish we didn't have to. We're looking at other ones as well. Okay, so Excel is awesome because no matter what you do, you will always use it. It's a great prototyping tool. Where you get into problems, is when you try to treat it like a programming language. Because as you get these really complicated spreadsheets, then they are truly software code. And they're software code without any of the protocols that are used to develop real software. And so you don't have version control. Anyone can adjust it. So there are a lot of examples out there where people have had disastrous results, right, by having this software, this ridiculously complicated problem solved in Excel, and there's a typo in it. There's something wrong in a formula. So you should use Excel for prototyping, for quick analysis, things like that. If you're creating something that is very involved and you want everyone to be able to do it, have someone code it, because then it's a much more formal process. It takes a little more time. But Excel shouldn't be a substitute for packaged software. All right. Any course on data mining and clustering techniques? Yes and no. So let me talk about the other courses, because as you guys know, you guys came in through SC1 and 2 now. We are developing 0, 3, and 4. So SC0 will be all about the mathematical techniques. And so we're going to focus in on optimization. Everything we did in this course, we'll focus in a lot more on that and apply it to other areas. And we'll also do statistics, probability, regression, all those kind of things, and really get people a sound grounding. Because you really should have, we want to do that before you take 1 or 2. But it wasn't developed first, so we had to go with what we had. SC2x now, which comes out in August, and I hope you'll all takes everything we've done so far, all the mathematical techniques, and says, okay, what happens in the real world? So we look at some of the complexities, some of the complications that happen. For example, in network design, if you don't take into account, and it crosses borders, if you don't take into account taxes, duties, and tariffs, then you're wasting your time. And so we'll start talking about that. What are some of the complications? So these are things that build on top of what we've given you. We've given you a great framework now of the basic fundamental trade-offs in supply chain, both in design and in control. The next course is SC2x. We'll talk about the complications and some of the more interesting practical concerns that are involved. And SC4x will talk about a couple things. One is, how do you handle the data in real life, and how do the different systems operate? The ERP, how does that work with an order management system, a warehouse management system, a transportation management system, and everything in between. Yeah. So someone asked a question of what will we be doing when we talk about data mining. We will a little bit. We'll introduce relational databases, but we're not going to go way deep into it, because there are other courses in there that in edX that you can take to help you get a much better understanding of some of these more of these better techniques, whether it's process, whether it's Python, any kind of coding. We will touch upon it. We're not going to go deep. This course and this curriculum is meant for supply chain practitioners, so you need to know enough to know what's going on, but you're not going to be a professional coder. We're probably not going to introduce you to R, for example. There are courses in that. This is not the course for that. All right, what else do I have? Okay, so a question on how to find the binary variable using Excel constraints when fixed costs are considered for planes. I think I answered that.
Yes, I think in the lesson we described it for warehouses, but I would be worth mentioning that the logic is the same.
Oh, for anything, for any facility. You can actually also do it. Sometimes, what happens if I have an arc? So sometimes there's a fixed cost on an arc. You do the same thing. So if any flow is on the arc, you set the same logical constraint that it triggers a binary variable, and you pay a fixed cost to it. So to have a fixed cost, you've got to have a binary variable. If you have a binary variable, you've got to have something that turns it on, and based on flow. Because what you're really doing, this mixed integer linear program, it's the linear program, the continuous variables that drive the binary variables. So and on the other hand, if you don't have any fixed costs, then you do not need to have binary variables, right? Everything's continuous, so it'll solve much faster. What slows these models down is when you get into integer programming, because then you get away from having this convex feasible region into having points, and it's a lot harder. There's a whole discipline in discrete optimization. All right. So a question, in our experience, supply chain network design is driven more by politics than modeling. What's my experience? Yep, it's true. And so here's the thing. It's not just politics. So politics means, for a lot of us engineers, politics means not the math, right? So why isn't the math driving it? And it's really all about the practical concerns. And so some of it could be that you want to grow. The model might suggest to close a DC. And I've done a project with a large CPG company where all the models in the world were saying, do not open a DC in the northwest part of the United States. It doesn't make sense, up in the Seattle area. And they continued to do it because they thought strategically, something the model isn't considering, the optimization doesn't consider strategy, it considers the cost as they are now. They kept it open. So the model was suggesting one thing, but they overruled it. This reinforces the point that the model doesn't make the decisions, people do, right? It's a decision support system. It's not a decision system. And so, yes, there's always politics. But to make your point, you've got to have numbers behind you. And so you've got to try to justify other people's opinions. All right. So this one's done. This one's done. What are the 3 keys to building a business case and presenting our network design analysis to management to drive a change in our company that prefers to maintain the status quo? I think you need to leave your company. No, I'm only kidding. The 3 keys. So you want 3 keys to do a network design, or you have a result and you want to try to convince them? Yeah. You've got to we'll talk more about this a little bit in 3 when we talk about supply chain strategy. Because we'll talk about how supply chain strategy needs to align to the business strategy. Some people argue that there's no such thing as supply chain strategy. It's really a supply chain tactics that support a business strategy. Whatever, it's a minor disagreement. But what you want to do is talk in terms of the CEO and the managers, the business unit owners who own the business. And so think of it in terms of the financial side. So I think week 4, we just released Jared's section. Is that out now? Week 5. So go through week 5. That's going to tell you how to translate all of the savings, because you're going to do a network design and you're going to say, okay, it saves X much in operational cost. You want to translate that now into better financial terms. And so you're going to learn about working capital, net present value, and how to really present this in the CEO's terms. And so the other thing is Watson's book talks about this a little bit. And I recommend reading up on that. There's some other finer points you can do. But it all goes down to just presenting the business case. Here's what we see. Here's what we see the benefits are. But it's helpful, I think, to speak in their language, which is really the language of finance. All right. All right. So I think we've had most of the questions that have come in. You guys around the table, Frederick, Eva, Roberta, anything that you guys want to say?
There were many administrative questions, but we're not addressing them.
Yeah.
Because we're not talking about administration.
Yeah,
That's right. And we're not talking about, no one's asking about graded assignments. That's good.
Specific questions about how to add a constraint. I don't think this is the forum to
we can.
cover that.
It's more technical.
It's more technical, yeah.
So I don't know what the best way is to answer the technical questions.
Some of them want to join again to the breakout room.
Okay. So why don't we do this? We have about 10 minutes left.
Yeah.
Can we do both at the same time? Can you be in the lobby and people in the breakout? Okay.
Yeah.
So
some of them want to.
Feel free to go to the breakout rooms. You don't need to listen to me jabber on. And then if there aren't any more questions, we'll just give it a pause.
Yeah.
Okay. Anything from you, Frederick?
Nothing from me at this point.
Eva?
No more.
Roberto? Sure.
No questions so far.
All right. Well, this was fun. Hopefully, give us feedback. I know you always do. Let us know how we do. Let us know. We'll try to improve it. But and also let us know if you think that we should do this more frequently, less frequently. Invite other people. Let me know. We tried to do it 10 o'clock in the morning for us is the common time when things are due. So we'll see if we think we should do this at other times. Let us know. All right. All right. I'm going to sign off. We'll keep the breakout rooms open for another 10 minutes or so. And it was good talking at you. I really couldn't hear you. I'm getting used to this now, though. All right. Thanks, guys.